We'll see electric field due to dipole at equatorial position. It is an electric dipole, minus q charge plus q charge, separated by separation 2a, center of the dipole O. This is A and this is B. We have to find electric field at equatorial position. This line is equatorial plane, this plane is equatorial plane, and we'll take a point P, and this P point is on the equatorial plane of the dipole, which is bisecting this dipole. Now the distance of this P point from center of dipole is R. Now we have to find what is the electric field at this point P due to this arrangement called electric dipole. First of all, I will mark the direction of electric dipole moment, and electric dipole moment vector is from negative charge to positive charge, and this is P vector. As we already know that the magnitude of P vector, it is equal to Q into 2A. Q is the magnitude of either of these charges and 2A is the distance between them. Now first we will find what is the field due to this charge plus Q. Now as the charge is positive, so the field due to this charge plus Q, it will be directed away from this, and this I will write as electric field due to this plus Q charge. And similarly, the charge minus Q, the field due to this charge minus Q will be attractive field, and it will be towards this. So this is electric field due to minus Q charge. Now what is the magnitude of this electric field due to plus Q charge and minus Q charge? So I need this distance BP and AP. Now in this triangle, this POB, this is a right angle triangle and it is hypotenuse. So this distance is simply, this PB distance is root of R square plus A square. And same is the distance this side. So I will write these distances. So this distance AP, and it is also equal to BP, and this is equal to root of R square plus A square. Now what is the field at this P point due to this positive charge plus Q? So electric field, I will write plus Q charge will produce is equal to KQ upon BP square. Now I have written the magnitude, it is the magnitude of field, and this is KQ upon BP. So BP square will be R square plus A square. It is the magnitude of electric field. So this is magnitude of this electric field. Similarly, the electric field that is produced due to minus Q charge, this is also having same magnitude, as the charge has the same magnitude and distance is also same. So this is R square plus A square. It is actually AP square, which I have written here. Now we can see that this electric field and this electric field both are having equal magnitude, but I have to find the resultant. So in order to find the resultant, I will draw this one axis and this another axis. Now this angle is suppose theta, and this angle will be symmetrically theta. Now this electric field due to positive charge, it will have two components, one in upward direction and one in this direction. Similarly, this minus Q charge electric field will have two components, this direction and this direction. As we know, these two magnitudes are equal, and these two angles, this angle is theta, so this angle will be theta, and this angle is theta, this angle will be theta. So these two charges, electric field, are equal, they are in opposite direction, so these two components will be exactly equal and they will cancel out. Now what we are left with is this component. So the component of this electric field and the component of this electric field, both in same direction, they will add up. And if you see, then this components I can write it as it is E plus Q, so it is theta, so here it will be cos component, cos theta. And similarly, electric field, due to this minus Q charge, its cos component. When we add these, we know that the magnitude of electric field in both cases are equal. So when we are adding, so what is net electric field at equator? So it is equatorial electric field. This is equals to E, due to positive charge, its cos theta component, plus E, due to negative charge, its cos theta component. So I know that both these are equal, so I can write it as 2E due to any of them charges into cos theta. So here we can write this as, this is 2 electric field due to this positive charge, this is K Q upon R square plus A square. Now what is cos theta? So cos theta, for this cos theta, will let us take this triangle. These two angles are alternate angle same. These two angles are corresponding angle same. So here I am taking this triangle. So in this triangle, cos theta is this A upon this hypotenuse. So this is A upon root of R square plus A square. Now when I solve this, so I will get it as, this is 2 Q A divided by R square plus A square whole to the power 3 by 2. Now this is the electric field. Now I should take the direction also. So what is the electric field direction, with direction at equator? So if we consider the direction, so this is the direction of electric field and this is the direction of dipole moment. So electric field is opposite to dipole moment vector. This is the direction of minus p cap. This is electric field direction. So this dipole moment vector and electric field both are opposite. So what I will do, I will write it as 2, we know that 2 into QA. So what is 2 into QA? It is dipole moment. So we can write it simply as K and this 2QA as P upon R square plus A square to the power 3 by 2. And the direction is opposite to the dipole moment. So this is dipole moment vector, and minus sign, it will give you a direction which is opposite to dipole moment vector. Now let us see for short dipole. Short dipole. As I have already discussed that short dipole, this length A, this distance between dipole is much smaller compared to this R. So I can see that this A is much smaller compared to the R. Now in this case, we will get this as E equatorial, this is equals to minus K P upon, if you neglect this A square, so this will be R cube. So again we get E equatorial is proportional to 1 by R cube. The magnitude is directly proportional to 1 by R cube. So this is the field due to electric dipole at equatorial position.